Hi, John McElroy here talking all things automotive. Right now, I'm talking with Pete Grabowski. He's the Chief Operating Officer of a company called SkillReal USA. They've got some dynamite technology that's really going to help the automotive industry. But Pete, number one, thanks for being here. Number two, what's SkillReal all about?
Thanks, John. Yeah, so at SkillReal, we've developed a very powerful software platform that allows us to take standard off the shelf cameras, augment them with proprietary undistortion algorithms, pair that with some of the world's best in class correction undistortion algorithms and digital twin alignment, allowing us to do billions of calculations per second to tell our customers exactly where their intended features are located compared to the CAD designs. And this is a transformative, very powerful technology for the automotive industry.
So let me simplify it. You are adding your own proprietary software to take standard everyday industrial cameras, make them super, super accurate so they can inspect things, compare it to the original CAD drawing of it, and make sure the two align. And if they don't align, you can point out where there's mistakes.
Yeah, that's correct. And it's a digital twin alignment process. So we're taking the customer CAD model and perfectly superimposing it onto the physical parts in real time. And this is possible with those billions of calculations, and it's only become possible to do in real time recently because of the breakthroughs with the NVIDIA GPU technology. It used to take a supercomputer 2, 3, 4 hours to do the amount of calculations that we're now able to do in just seconds.
So give me some real world example. Let's say I'm an automaker doing stampings. They're coming off the stamping
Mhm.
presses. What does your system do?
So essentially what our system does is we'll take an image of each part as it comes by in real time, snap that CAD model to it, and individually look for, in a case of stampings, we look for the holes, ensure that the holes are present and in the correct location. And then we output a report so that they know that the next part that comes through, that last part was good, and the next part that comes through is ready to be inspected as well.
Okay, it's got to go beyond just looking for holes. Let's say I get multiple stampings, I weld them all together. What does your system do?
So we can look for all the manufacturing features present. We'll look for the spot welds, the arc drawn weld studs, the holes. We're also expanding the platform to rivets, weld nuts, MIG welds. So being able to have a one-stop shop for an entire end-of-line assembly and do a check at the end of line to ensure that all of those hundreds of features are present in the correct location, all under the umbrella of one software platform.
And so you said real time. In other words, this isn't taking that assembly or that stamping, putting it in an inspection fixture. You're talking as this stuff comes down the line.
Yeah, and I'll kind of show you what they used to do or the legacy, what they're still doing in a lot of cases is they'll make an assembly, for example, with a laser cut application. You put blanks into the laser cut booth. The machine runs to cut those holes. The operator then has to pull those parts off of the tool, walk over to a dedicated checking fixture, place them in, and run a logic, which is this checking fixture is very complicated, highly specialized machined, has a PLC logic, and that takes a lot of operator movement, and these machines wear out. It takes up floor on the factory floor, and then you have to load these parts back into the bin. So what we're doing at SkillReal is doing this all in station on the laser cell itself. As soon as those parts spin out, we take the image, we can quickly do that check, relay that information back to the information system, and the customer has confidence that that next cycle is not going to start if our system detects any errors with that last part. So you get that in-station, in-quality check.
Okay, so that's once things are being made. What about upfront of that, i.e., setting up a new plant, retooling a plant, or anything like that? I got to believe this plays a role there.
Yeah, so this platform has a tremendous implication to speeding up the time that it takes to build a new line. Automakers oftentimes are spending 8 weeks plus to build a new line. With this, we can do virtual
When you
commissioning.
say a new line, you mean like a body shop line
Yeah,
or
a new body shop line, ensuring that everything is dialed in. They're oftentimes waiting on physical parts to come in to do the robot path and all of that. Now we can do it digitally in the virtual environment with the digital twin.
go into that more? What do you mean do the digital, the robot path?
So we'll take the robot and the PLP points that you're going to place a body on, and what we can do with our software is put a digital twin version of that assembly, and then allow the customer to direct the robot in the virtual environment with the physical robot, and plan that robot path out ahead of time, so that when the tooling is ready, all you need to do is upload that virtual robot program to the tools and you know that you're ready to go. You don't need to spend all that additional time to dial everything in.
So, because often when you're getting close to production, some parts aren't ready. You're saying no problem. Just
Right.
take the CAD drawing, if you will, and teach the robot how to weld or where to weld based on that digital part.
Correct. And another beautiful part of this system is if there's an engineering change and you have a spot weld move or a stud move, all you need to do is upload a new version of that CAD model, and you can redo that one little area that needs to be corrected. So, it really helps itself along the entire life cycle of the assembly process.
You said it might take 8 weeks to set up a body
Mhm.
shop. What can you get it down to?
With our system, we believe we can cut 3 weeks out of that time and get it to 5 weeks.
That doesn't sound like a lot to some people, but if you're trying to launch a product, 3 weeks is
Yeah,
massive.
every day that you're not running production, you're losing a lot of money. So
Oh.
it's tremendously valuable for the OEMs.
hmm Um, we've been talking about body shop stamping. So where else would this apply?
Yeah, so end of line quality checks is a huge area. I mean, there's a lot of applications for this within automotive, but just in manufacturing in general. Anywhere that you need to ensure that your CAD design or that your design meets your production intent, you can use this technology to do a digital twin alignment and check those features, making sure everything is present. The end of line one is huge for automakers because there's a tremendous labor cost pressures. And with our system, we can implement our technology oftentimes in existing fixturing, existing tooling. It's not a major tear up to the line, but we place these cameras and we can augment what the human is doing, have them go onto higher value tasks, and have the inspection be done completely by our software platform.
hmm Uh, you said you can take sort of just generic industrial cameras and apply your software and make it very accurate. How accurate?
So we can get to a plus or minus 0.2 millimeter true positional accuracy with our system. And that's continuously improving. We have some great minds working on the technology, and we're continuously driving that lower and lower. Right now, we're using single cameras and our digital twin alignment to gather depth information. We're also moving towards stereo camera applications to become even more precise.
But if you're taking simple cameras and improving them with software, I got to believe you've got a cost advantage doing it that way.
Definitely, we're about 20 times the cost of the traditional, very expensive optical.
20 times less, you mean?
Yes.
Yeah,
Yeah.
very interesting. Um, so what's been the reaction to the industry? I mean, I know you guys are brand new. You're just going out there. What's been the reaction?
So every customer that we talk to sees an application for this technology, and it's really on our side is a bandwidth issue of just how many features can we build in the shortest amount of time. But there's the messaging definitely resonates with the OEMs and the tier ones. They're spending a lot of time, a lot of money, and God forbid they have a spill in their current production process. I mean, they can pay for itself very easily, very
And spill,
quickly.
you don't mean just spill it on the ground, right?
No, no, a production spill, a part that you make that's not built to print gets out to a customer. That's very costly. You have to recall those parts, quarantine them, and then rework and repair costs. So with our system, being able to check in quality as soon as that part is made, validate it, and then with our full comprehensive report, you have a timestamp. You know exactly which part was made that was incorrect, and you can rework that one part rather than hundreds of parts.
I'll press you on it. Can you name any names of companies that have bought your system or are working with it?
So we're working with some of the major OEMs and tier ones, both in North America, but also in Europe. One name that I can say is GNS in Canton. They've been a very great partner of ours. We're developing our laser cut hole application for them. And they've already bought follow-on systems from the initial deployment that we've done. So
What's GNS do? I don't know their name.
GNS is a stamper, a hot stamper. And so the hot stamp blanks, but then they'll cut the holes and do final assembly on those before sending them for the complete assembly at the OEM level.
Got it. I wanted to hear your reaction to GAMIC, the Global Automotive Mobility Innovation Challenge, because that's how I learned about SkillReal.
Yeah.
There's this, it's kind of like a Shark Tank for startups to present their stuff. SkillReal obviously was one of the finalists in that. How's it been for you being part of GAMIC?
Yeah, GAMIC was a great experience for us, and at SkillReal, we really saw the GAMIC competition as our coming out party to the North American market. We've kind of been operating in a stealth mode. These are very specialized algorithms that we've been developing, and we didn't want to enter the market until the time was right. And the time was right earlier in the spring, and that's when we started to get engaged with the GAMIC process. And I think it was just overall a great experience and gave us a lot of really good exposure to the OEM tier one levels and just the marketplace in general.
You're the COO of the U.S. branch of
Mhm.
SkillReal, but SkillReal is a Israeli-based company, right?
That's correct. All the algorithms, the digital twin process, the camera undistortion algorithms, all developed by the Brain Trust in Israel. These are some of the world's best mathematicians that have developed the core technology. And they found us as the U.S. division as the automotive expertise. So taking that really great technology, applying it to automotive, speaking the language of the customers, helping with the deployments and the refining for automotive specifically. I think that's a key point, is that this technology at this point is now specifically targeted to body in white manufacturing and the automotive industry in general.
Yeah. No, it's a great story. I mean, an innovative, low-cost approach that can improve quality, shrink cycle time. I don't know what's wrong with it. There's nothing, no downside that I see on this.
Yeah, and like I said, it really resonates with our customers, especially when we can walk into a conference room. They send us a CAD model and put a part in front of us that we've never seen in person before. And in 5 minutes, we can upload that CAD model, take an image of it, and do a full comprehensive report and give them dimensional data on all of those manufacturing features. This is something that helps a lot with line builders and integrators, that when they're building a line offsite before they bring it to the production facility, they're spending 20 plus hours bringing those parts back and forth to the CMM lab to measure spot weld points. Those CMM lab guys are not appreciative of that. And we can cut that time dramatically down. They know, okay, we need to dial in these spot welds and cut that time, that cost savings in the labor of the CMM, and shortening that ramp up is tremendously powerful.
Well, good. Pete Grabowski, thanks for your time.
Thanks, John.